Good evening, everyone. Am I audible?
Yes, sir.
Is my screen visible to all?
Yes, sir, visible.
Thank you. Okay, so let's start. Good evening, everyone. I hope you have gone through all the lectures of week 2 of this course on fluid mechanics in NPTEL. And as you have must realize that this particular course on fluid mechanics, the week 2 lecture was basically related to hydrostatics. So, what exactly is hydrostatics? It is basically the behavior of the fluid when it is at rest. So, under this, the major topics that were covered included the pressure, the pressure forces, different types of pressure forces. Then, what are the forces on different types of surfaces when kept immersed in fluids? Then another important topic was related to Archimedes principle. Okay, but the most important topic was pressure measurement. Now, why I said it was the most important topic, because pressure measurement by making use of different types of manometers and the concept of pressure is very important if you are appearing for any competitive examinations like GATE or engineering services exam. So that's why you need to practice as many problems as possible related to uh, pressure measurement, and sometimes you can also expect questions from Archimedes principle. So that is force of buoyancy. So we'll try to discuss some problems today, and you please sincerely practice all the problems in the different reference books that we have discussed in our previous week lecture. So to begin with, uh, this was already discussed in the week 2 lecture, but since it is very important and sometimes it create confusion, I thought of once again elucidating this particular affair. So what is basically pressure? You all know what is pressure, but the concept of fluid pressure, you need to imagine the concept of fluid pressure. So fluid pressure is something, say we have, say this is a fluid parcel, a big fluid parcel. I'm not talking about infinitesimal fluid parcel, but rather you can consider this as a balloon. Now when the pressure acts, it basically acts like this, that is uniformly on the entire surface of the body. On the entire surface of the body. So this is how the pressure acts. But you must have studied about, or means even in lecture 2 it was covered about Pascal's law. So what is the statement of Pascal's law? Pascal's law states that when the fluid is at rest, not stated, basically the physical implication of Pascal's law is when the fluid is at rest, then at a particular level, means at a particular elevation, okay, if it is fixed, then the pressure intensity in all the directions at a particular point, the pressure intensity in all the direction, it is same. Okay, so that was Pascal's law. But for practical purposes, we make use of manometers, and we need some reference for measuring pressure. So what is that? So the baseline for measuring pressure is the absolute zero, okay, which basically refers to complete vacuum. So absolute zero, there is no air, so it is complete vacuum. Okay, so say you are measuring the pressure at this point. Okay, you are measuring the pressure at some point A, or you are measuring the pressure at some point, say this is some point, and you are measuring the pressure at this point A. Okay, so there are different ways you can consider different datums or different reference levels. So if you consider your complete vacuum as your reference level, then the pressure at this point with respect to the complete vacuum is known as the absolute pressure, as shown in this particular figure. Okay, so this is your point A, and when you are measuring the pressure with respect to the absolute zero, it is the absolute pressure. Now what is atmospheric pressure? Atmospheric pressure is basically the pressure exerted by the atmosphere. Okay, we know that, say this is, say our earth surface, and above it we have up to certain distance we have a layer of air. Okay, there are different layers, but the combination of all these layers constitute the atmosphere. Now this atmosphere comprises of different gases. Okay, and different it has many sublayers, and each sublayer has different properties. We are not interested in that. Our idea is we want to define something known as atmospheric pressure. And what is atmospheric pressure? the pressure exerted by the total atmosphere. Now, if you go outside this atmosphere, then there is vacuum. Okay. Now, suppose you want to measure the pressure at some point here. Okay, say at this point. You want to measure pressure at this point. Then, above this point, so what is the pressure above this point? Above this point, this is the depth of the atmospheric layer, the depth. Okay, so as we have seen the static pressure, it is H times rho of G. So this is the pressure. Now if you go down, this pressure keeps on increasing. Okay, so keeps on increasing. So on the earth's surface, on the surface of the earth, the pressure exerted because of the total depth of the atmosphere is the atmospheric pressure. So this is, say, our atmospheric pressure line. Okay, so when you consider the atmospheric pressure as the reference level or the datum level, and when you measure the pressure with respect to the atmospheric pressure, it is known as gauge pressure. Means the same point A, when the pressure at same point A is measured with respect to the atmospheric pressure level, it is known as gauge pressure. Now sometimes it may be the case, for example, that for example, say this point. Now at this point the pressure is not the total atmospheric pressure. Okay, at this point the pressure is not the total atmospheric pressure, because the total depth of the atmosphere is not exhausted here. So there may be some points where the pressure is less than atmospheric pressure. So there, if you measure with respect to the absolute zero, it is the absolute pressure. Okay, whatever you are measuring with respect to the absolute zero, it is the absolute pressure. But if you measure the pressure with respect to this atmospheric pressure, this pressure is known as vacuum pressure, because when you are measuring with respect to the atmospheric pressure, then what happens? Atmospheric pressure is considered as a zero level, and something is less than zero means it is negative pressure. So that's how it is known as vacuum pressure. So mathematically, what are the relations? Absolute pressure is basically atmospheric pressure plus. Okay, it's a request to all of you. If you're asked to join at 7, then please join by 7:05. After that, it becomes very difficult to continue the lecture, because in the last class also I have seen that people are joining after means even after 15 or 20 minutes have passed. So from next week onwards, please try to join by 7:05, and after that I will not admit any more participants. Please make it clear. So absolute pressure is atmospheric pressure plus gauge pressure. So that is your absolute pressure. So say you are calculating the pressure at this point, so it is atmospheric pressure, okay, plus the gauge pressure. And vacuum pressure is atmospheric pressure minus the absolute pressure. Okay, so these are some basic relations that will make use of. So let's move to our first problem. Please read the problem carefully. The problem states that the density of a fluid mixture rho in kg per meter cube, that is in SI units, in a chemical reactor varies with the vertical distance z in meter above the bottom of the reactor according to a particular relation. Okay, according to a particular relation. The density of a fluid mixture rho in kg per meter cube in a chemical reactor varies with the vertical distance z in meter, which is measured above the bottom of the reactor according to the relation. So density varies like this. Okay, so density is basically a function of z. What is z? Z is the distance from the bottom of the reactor. Now assuming the mixture to be stationary, okay, means static, determine the pressure difference between the bottom and the top of a 60-meter tall reactor. Okay, so what is the situation? Situation is basically there is a reactor, okay, which is 60-meter tall, and there is a mixture of fluid present inside the reactor, but the density of the total fluid mixture that is present within the chemical reactor, rho, in kg per meter cube is expressed as a function of vertical distance z. Now what is z? Z is the distance of any point which lie distance of any point from the bottom of the reactor. Okay, and Z is in meter. Rho is in kg per meter cube. Z is in meter. And for that 60-meter tall reactor, inside which the mixture is stationary, you have to determine the pressure difference between the bottom and top of the wall. So please take 2 to 3 minutes and see whether you can solve this problem or not. And after 2 to 3 minutes, we will discuss the solution. I hope the problem is clear. Okay, so someone wrote minus 1.22 Pascal, then 5252.88 Pascal. Okay, fine. So let's see. See, the final answer, though, is very important for competitive exams, but the concepts and how you have done it, it's very important. Okay, so this is basically the reactor. Say a rough sketch of the reactor, which is 60-meter tall. Okay, so this is the T marks the top of the reactor, B is the bottom of the reactor. Okay, T marks the top of the reactor and B marks the bottom of the reactor. Now, what will be the pressure on the top of the reactor? And by pressure, I mean the see here nothing has been mentioned whether uh, if you're finding, say, by pressure I mean the absolute pressure. Okay, and if you want you can find the sorry, by I mean the gauge pressure. If you want you can find the absolute pressure also. For finding absolute pressure, what you need to do is you need to add the value of the atmospheric pressure. Okay, so for our purpose we assume a constant value of atmospheric pressures, but a more simple way with less calculation is basically to adopt the gauge pressure, is to adopt the atmospheric pressure as the reference level and to obtain the gauge pressure. Now at the top, what is the fluid depth? Fluid depth is 0. So the pressure on the top, that is Pt, is equal to 0. At the bottom, the fluid depth is basically 60 meters. So rho b is basically the density at the bottom. Then G is basically you can choose 9.8 or not 10, whatever is given in the is asked in the question. And then what is age? Age is 60 meter. Okay, so the variation for density was given. Okay, now if you look carefully, it, the density depends only on Z. And what was Z? Z was the distance from the bottom. Okay, Z was the distance from the Z is basically the vertical distance from the bottom of the reactor according to the relation. Okay, now what is the total height of this reactor? The total height is 60 meters. So if you put 60 meter, you'll be getting, so somebody obtained the answer, if I'm not wrong, as 5252.88 pascals. So that is basically the solution. So it's a very simple problem. uh, Excuse me. Now the next one is find the absolute pressure. Okay, you have to obtain the absolute pressure at a depth of 5 meter below the surface of a liquid of relative density 0.85. The barometer reading on the surface is 750 millimeter of mercury. Okay, now here one important thing that you should always remember. See, we all know that standard means the standard value of the density of water is 1000 kg per meter cube. You should also remember, always remember the density of mercury. So what is the density of mercury? It is
13600 kg
zero.
per meter cube.
Yeah, so 13,600 kg per meter cube, or a relative density of 13.6. Okay. Now you have to find the
13.6 gram per cc.
yeah. Thank you. So now what you have to find is you have to find the absolute pressure. Okay, you have to find the absolute pressure at the depth of 5 meter below the surface of a liquid of relative density 0.85. Okay. Now the barometer reading is 750 mm of mercury. Now what is the function of a barometer?
To measure the local atmospheric pressure.
Yeah, it measures the local atmospheric pressure. Now since in the question it is asked to find the absolute pressure, you definitely need the local atmospheric pressure, so that's why the barometer reading is given to you. And the relative density of the liquid with, is given as 0.85, so you can easily compute the density from this relative density. And then at a depth of 5 meter you have to find the absolute pressure. So please try this.
So can you please show the question once again?
Yeah,
Yeah.
sure. Yes, somebody obtained 101,437.853 Pascal. Okay, let's see. So absolute pressure P is equal to gauge pressure, which I have denoted as Pg, plus atmospheric pressure, that is P ATM, P atmospheric. Now, what will be the gauge pressure? Gauge pressure is basically, uh, it is given to you that there is a fluid, and say this is the free surface of that fluid. For example, say this is the free surface of that fluid, and at a depth of 5 meters below, at a depth of 5 meter below that fluid, you have to obtain the absolute pressure. Okay, so gauge pressure will be basically rho GH. Now, what will be rho? 0.85 is the relative density multiplied with the density of the water, that is 1000 kg per meter cube is the density of the particular fluid under consideration. 9.81 is the acceleration due to gravity, and into multiplied by the height h. Okay, so this gives us approximately uh, 41,600 692.5 Pascal of gauge pressure. Now atmospheric pressure, it is given to you. What was given to you in the question? 750 millimeter of mercury. Okay, 750 millimeter of mercury. It is given to you 750 millimeter of mercury is the atmospheric pressure. So 750 multiplied with 10 to the power minus 3 makes it 750 to 10 to the power minus 3 meter. Okay, into 13,600 kg per meter cube. Okay, into 9.81. Okay, so rho, this is basically rho, this is G, and this is H, gives us this many Pascal as the atmospheric pressure. Now if you add these two, okay, you'll be getting the answer in Pascal, and if you divide it by 1000, basically get the answer in kilopascal. Okay, so how much you got? 101,437. It's a little bit, someone got 0.141 megapascal. Ritoban Maiti, 0.141 megapascal. You just check your calculations once again, or there might be some calculation issues with my calculation also, but the idea is you should know how to solve this problem. I hope the idea is clear. If it is asked in the question that you have to obtain the absolute pressure, then you first of all obtain the gauge pressure, and then you add the atmospheric pressure. Now sometimes, see, in most of the questions you will find that the barometric reading will be given to you, but if the barometric reading is not given to you, then what you will do, you will take the standard value of atmospheric pressure, which is 760 millimeter of mercury, okay, or 10.33 meter of water. Okay, whichever you like to use, you can
Sir,
use. Yeah.
so here in the question, like it was given that relative density is equals to 0.85.
Yes, yes.
So we have assumed the other fluid in the relative density to be water,
Pardon, I'm not yeah.
but
Yeah, relative density is
I'm
0.85.
sir, yes, sir. Sir, I'm saying that relative density is more of a general term. So relative density is basically a ratio of any two density of fluids.
Yes,
So
any relative density is basically ratio of entry to density of fluids. That is fine, but the thing is, whenever in the question, if the other fluid is not given to you, the standard is water. Okay, if it is given in the question that the standard fluid, the
okay, sir.
standard,
Okay.
yeah, then you can use that. You have to be careful. You are very much correct. Okay, but in this particular type of questions, and you will find
Okay,
many
sir. Thank you.
questions, if the standard fluid is not given to you, then you take it as water. Okay,
Okay, sir.
yeah, thank you. So, yeah, so I was talking about the atmospheric pressure thing. So, if the local barometric reading is given to you, you have to use that value. Otherwise, you use the standard value, which is 760 mm of Hg, that is mercury, or 10.33 meter of water. Okay. Now, moving to the next question. This is a particular setup. Okay. And from this setup, from the data given in this setup, you have to determine the difference, the pressure difference between points A and point B. You have to determine the pressure difference between point A and point B. So this is basically a manometer. Okay. So this is a pipe. So this is basically a manometer. Can you tell me what type of manometer is this? Anyone?
Differential YouTube manometer.
Yeah, this is a differential YouTube manometer. So the role of a differential YouTube manometer is basically it obtains the pressure difference, or it calculates the pressure difference for between two pipes. Maybe say this is a pipe and this is a particular pipe, and at a particular cross section a manometer, a differential manometer is connected. So it finds the pressure difference. So you have to obtain the pressure difference between point A and point B. Now, uh, looking at this particular sketch, can you tell me which pipe is having higher pressure qualitatively?
A at left side, at right side,
A, pipe A. Okay, right side. Fine. Okay, let's see. Okay, why did you tell pipe A? What is the logic?
because mercury is going down.
Okay, fine. Fine. Thank you. So, please try this question. Okay, please try this question. For this, you take 3 minutes, 3 or 4 minutes, and please try this question. Somebody, answered 97.5 dynes per centimeter square. Okay, that we need to check. But looking at the value C, please remember one thing: until and unless it's mentioned in the question, please try to make a habit of calculating everything in SI. Okay. But if in the question it's given that you have to use the CTS unit, then you have no other option. You have to go for it. Otherwise, please use SI. There are some benefits uh, which you will understand might be at a later stage, but there are definitely some benefits of it because it is a internationally accepted form of measurement. Anyways, so let's look at the solution. So if you write the equation, okay, if you write the pressure equation, if you write the pressure equation above this line, that is xx, which represents the mercury uh, level, the top level of the mercury on the right limb. Okay, on the right limb. So on the left hand side, it will be pressure B plus the pressure because of this oil, which is having a relative density of 0.8, plus this much depth, that is 8 centimeter depth of mercury. Okay, and on the right limb, it is the pressure on A, that is PA, plus the pressure due to the oil having a relative density of 0.7. Okay, now the rest values are all given to you. So 0.8 into 1000 is basically, now in this particular question also somebody asked in the previous question, right? So since nothing has been mentioned about the standard fluid, so you take 1000, that is water, as the standard fluid. Okay, you consider water as the standard fluid. Sorry. Plus this is mercury. So for mercury, the density is 13,600 kg per meter cube, multiplied with, it was the height of the mercury was 8 centimeters, so it has been converted to meter, so 0.08 meter. Similarly, equal to, on the right limb, what is the density? Density is 0.7 into 1000, because the relative density was 0.7. So after solving, you'll be getting around 9564.77. So somebody, yeah, uh, 956475, yeah, that is fine, that much error is accepted. Now I hope this problem is clear. Let's move to the next problem. Okay, so this is basically a tank. Okay, now this tank, there are three different strata or layers of fluid. The top strata is basically air, then in between there is a oil which is having a relative density of 0.75 and having a depth of 150 centimeter. Then there is water. Okay, then there is a manometer connected to it. Okay, there is a manometer connected to this tank, and the manometer is open to the atmosphere. Okay, you have to calculate the value of PA. Now what is PA? You can see that there is a gauge, pressure gauge here, A. So basically what is the pressure at A? Need to calculate. Okay, so how will you proceed? Or please try this problem. I am giving you again 2 minutes or maybe 3 minutes. Please take 3 minutes and try to obtain the answer and write in the debit messages. I'm waiting for your answer. So this is the figure, and after 3 minutes we'll go through the solution. No answers yet. So let's proceed to the solution. It is a very simple problem. See, if you look carefully, you can solve this question. Okay, you can solve this. Yeah, somebody wrote 9781551 Pascal. Okay, let's see. So you can solve this problem whether by taking the absolute zero as the reference, or you can take atmospheric pressure as the reference. Okay. Now, until and unless mentioned otherwise, it is better to go for uh, the gauge pressure calculations. The reason is it saves some computations. Okay. Now let's see. So if you consider this side, okay, so this PA is basically the pressure because of this air, okay, this air column. Then the pressure because of the soil, which is having a relative density of 0.75, and then we have water. Okay. So what is the depth of this water column? See, you can see that 200 centimeter. Okay. From here to here, that is the bottom of this particular tank, it is 200 centimeter, but 150 centimeter is oil, so this much is 50 centimeter plus 10 centimeter. Okay, so the total depth of water above this line x-axis is 60 centimeter. So PA plus 0.75 into 1000 means relative density of the oil multiplied with the density of water. We obtain the density of the oil into 9.81 into 1.5, because 150 centimeter converted to meter. 150 centimeter is the total depth of the oil layer. And then we have water, so 1000 kg per meter cube into G into 60 centimeter converted to meter, 0.6. So this will give you PA. Okay. So once you obtain PA, now you might have understood from these calculations that we are assuming atmospheric pressure as the reference level. That is, we are obtaining, these are all gauge pressures. Okay, these are all gauge pressure. Now, if these are all gauge pressure, okay, and on the left limb, this is mercury, and what is the depth of mercury? It is 10 centimeter. So density of mercury into G into 10 centimeter converted to meter, so it is 0.1 meter. So this is basically the equation. Okay. And then finally PA is equal to minus of 3.58 kilopascal or minus of 3580.65 pascal. Okay. So approximately minus 3580 pascal is the value of PA. So it is negative pressure. So basically it means that here the pressure is basically vacuum pressure. Why? Because the pressure is less than atmospheric. Now see, on the top of this, it is exposed directly to the atmosphere, and that's why you have not taken this value. Okay, because we are measuring with respect to the atmosphere, so that's why this value is 0. So that's why PA is minus of 3.58 kilopascal. Okay. So did anybody obtain that answer? Yeah. And absolute is fine. Good. Good. And in the question, see, if you are sitting for any competitive exam, most of the times it will be mentioned whether you have to obtain PA in terms of gauge pressure or in terms of absolute pressure. It will be mentioned in the question. So you need to be very careful. Now moving to the next question. It is basically related to the forces on hydrostatic surfaces. Now the problems on forces on hydrostatic surfaces are very simple, but the only thing that you need to remember is you need to remember the property of the surfaces. Okay, I have taken a very simple problem. So there is a rectangular plate which is 0.6 meter wide and 1.2 meter deep, and it lies within a water body such that its plane is inclined at 45 degree to the horizontal, and the top edge is 0.7 meter below the water surface. We have to determine the total pressure force on one side of the plate and the location of the center of pressure. So basically there is a plate, okay, rectangular plate which is 0.6 meter wide, 1.2 meter deep, and it is inclined at 45 degree. Okay, so this is the situation. So this is a rectangular plate which is 0.6 meter wide, 1.2 meter deep, and it lies at a depth of, means its top edge lies at a depth of 0.7 meter below the free surface of water. Okay, and you need to obtain the total pressure and the location of the center of pressure. So what is the location of the center of pressure? Say this particular G is a centroid and the center of pressure lies at a distance of x dash. Okay, so what will be the value of x dash? X dash will be 0.7 plus this much distance a. So I have written 0.7 plus a. So what is a? Sorry, what is a? This distance is a. Okay, this is 0.7 and this is a. Now what is a? If you apply simple trigonometry here, what is a? A will be 0.6 times of sine 45 degree. Okay, it will be 0.6 times of sine 45 degree. Fine, if we apply simple trigonometry, it is 0.6 times of sine 45 degree. So basically the value of x dash is 1.1243 meter. Then total pressure will be what? Rho g ax dash. So rho is density of water because the fluid given here is water. Okay, then uh, G is 9.81. Area of this rectangular plate is 0.6 into 1.2 and x dash is 1.1243. So the answer is 7941.2 Newton. Okay. And what is the expression for center of pressure? The expression for center of pressure is Ig sine squared theta Ax dash plus. So this is a very standard expression. What is Ig? Now this is very important. Ig is the moment of the second moment of area or the moment of inertia. So these surface properties are very important. You take any standard book on fluid mechanics, you'll find something like this. Okay, a table. So the standard shapes that are normally asked is rectangle, triangle, circle. Okay, sometimes they may ask you a semicircle and then a parabola. Okay, but this is a very comprehensive table. Please try to for competitive exam means you should know how to derive these expressions for the location of the centroid and the moment of inertia about the indicated axis, means whether it is a centroidal axis or any other axis. Okay, and you should also remember, because when you are sitting for competitive exams it is difficult to always derive these things because time matters. So you take any standard book on fluid mechanics. Okay, you'll find a table like this, or even in some books on engineering mechanics you'll find a table like this. Okay, and for each of these common geometrical shapes you please try to remember what is the location of the centroid and what is the value of the of inertia. Okay, so this is the direct application. So moment of inertia is bd cube by 12. Now d is basically the dimension which is raised to the power of 3 is basically the dimension, okay, through which the axis about which you are finding the moment of inertia it cuts. Okay, so where this ig is with respect to the centroidal axis, that is with respect to g, so it cuts the dimension 1.2 meters. So it is basically 0.6 into 1.2 cube 1.2 raised to the power cube by 12. Okay, so sorry, this is the value of ig 0.0864 meter to the power 4, and then simply by using these values in this expression you will be getting the location of the center of pressure, that is h dash from the free surface, which is 1.1776 meter. Okay, now let's move to the next problem. Yeah, so there is a spherical object. Okay, there is a spherical object of 1.5 meter diameter which is completely immersed in water in a water reservoir, and it is chained at the bottom. Okay, so there is a sphere, a spherical object whose diameter is 1.5 meter and it is completely underwater in a reservoir and it is chained to the bottom of the reservoir. Now if the chain has a tension of 5.5 kilonewton, okay, means after the chain has been used for restricting the movement of the sphere, okay, or it has been used on the sphere, there is a tension on the chain which is 5.5 kilonewton. Now, what you have to do, you have to find the weight of the object when it is taken out of the reservoir into the air. Okay, basically you have to find the weight of the sphere. Okay. So, can you tell me how you can obtain the solution for this problem? How you can find the weight? Anyone? Can you tell me how you can find the weight of this object? So what is the scenario?
Sir,
Scenario
we can
is,
use the Archimedes principle
yeah,
here.
definitely you can use the Archimedes principle. So this is basically the bottom of the reservoir, and this is the sphere. Okay, and the sphere is chained to the bottom by means of chained to the bottom. Okay, and because of this there will be a tension. Okay, there will be a tension on this chain. Okay, now what will be the direction of this tension? And this is completely,
Downward.
yeah, can you repeat? I didn't hear you.
So towards the bottom, I think.
Okay, towards the bottom means the downward side. Void in the downward side. Why downward side?
Because tension force is
Because
always
buoyant
acted
wave will be.
toward.
Yeah. I think two of you are speaking simultaneously. Please say one by one.
Because sir, buoyant force will be acting in the upward direction.
Huh? Yeah, I couldn't listen. There was a lot of disturbance.
Upward force will be a buoyant force.
Okay, in the upward direction there will be a buoyant force. Okay, the upward direction there is a buoyant force, and you are telling that it is balanced by this tension T. Is that the logic? Am I getting your logic correctly?
Yes, sir.
Okay, then what about this weight? What about this weight?
So it will be acting downwards.
No, I'm just asking that the force of buoyancy is acting in the upward direction, and you're telling that it is balanced by the tension. Okay, so the tension is something which is coming into the picture because you have chained the sphere. Okay, you have chained the sphere. Okay, by means of means there is some obstruction, and because of that there is a tension. Okay,
Yes, sir.
yeah. Okay, fine. So see, I have not uh, included a solution of this problem, but I want all of you to solve this problem and tell me what is the answer. Okay, you please solve this problem. So what will be the equilibrium equation for this? FB will be equal to W plus T, right?
Yes, sir.
Yeah. So you have all the data given to you in this particular problem. So please calculate the value of the weight W, okay, and tell me. I have not done the calculations for this question, so let's see. Few more answers. I'll try to go with the majority. So, okay, some Rajesh obtained 11,835 Newton, and someone else obtained 7,068.5 Newton. Okay, 7.33 kilonewton. So these two answers are close. Pradeep Kumar obtained 133.185. Don't know, means this and kilonewton is a little bit unrealistic answer, but can't say. Okay. Anyways, during next week's session, I'll first of all confirm this answer. Okay, I'll solve it by myself. I'll discuss the solution, and then we'll move to the contents of the next week. Anyways, thank you very much. Let's end today here. Bye.
Hello, sir.
Yeah.
Thank you.
Sir,
Yes.
I just enrolled after the previous problem solving session. Am I able to get the solved answers of past session, please?
See, I'm not getting your question. Means you have enrolled after the
The previous,
submission of assignment one was over, right?
no, sir.
Huh.
The due date is coming 10th, tomorrow.
Tomorrow.
Yes, sir.
Tomorrow. I'm not getting your question. Means tomorrow.
Tomorrow is the date of submission of assignment 1.
Okay. See, regarding the data submission of assignment, means the last week session we are talking about, right?
Yes, sir.
Yeah, there is a YouTube channel. YouTube channel. I'll just share the link. Okay, I'll just share the link here. Uh, just wait, just one sec.
Excuse me, sir.
Yeah.
Sir, I have a minor doubt regarding this last question.
Okay. Tell me. Yeah, please ask. Hello everyone. Welcome to the
Sir, can you
week
please
for fluid mechanics
zoom
of
on to that
NPTEL.
figure that you have made on the board?
Just wait. Just wait. Yeah, this particular question. Hello.
Sir, this.
Yeah,
Yes, sir.
yeah.
Here, basically, the anchorage is from the bottom.
The anchorage is from the bottom.
Uh,
Yeah. Yes.
But for example, a body is immersed in water from the top. Okay,
Hmm.
where anchorage is at the top.
Your voice is breaking down.
The
Yeah.
net.
Yeah. The body
I'm
is.
saying that a body is immersed
Hmm.
in water,
Hmm.
so there will be a buoyant force acting on it, and the net weight will get reduced. And but that net weight will be acting in the downward direction.
See.
So, but here the
Archimedes principle, what does it states? It states that, see, whenever a body is underwater, okay, whatever volume of that body, so no, not water, say any fluid, whatever volume of that body is inside that fluid, that much volume of the fluid will get displaced. Is it clear? Is
is
it okay? Okay, fine. That is the first thing. Second point is, whenever this body is inside that any fluid, okay, it may be completely immersed, it may be partially immersed or submerged, okay. What is the
yes, sir.
magnitude of this force of buoyancy? Magnitude of this force of buoyancy is the
Weight of
weight
water
of
is
the fluid
Weight
which
of
has
the
been
water.
displaced, right?
Sir.
Yeah. Okay, so these 2 points are clear, right?
Yes, sir.
Yeah. Then what is your question? If
Sir, I have a doubt regarding the orientation of this diagram. Shouldn't this the anchorage point shouldn't be like on the upper side, and
encourage, no, see,
shouldn't
it is clearly, see, this particular diagram is not what we are drawing, okay. It is something which has been mentioned in the question, that is it is chained to the bottom. So this basically, this particular line which represents T, this represents the chain, okay.
okay, okay, okay. So I think I got the point. I
Yeah.
think that the density of the body might be lighter than the density of the
Okay, okay. Now I
that
am
is the
getting your
fluid in
point.
which is
Okay, okay.
immersed.
You are telling that. Okay, now I
Yes,
got. Yeah, got your question. Means what if it starts moving downward? Yeah, yeah. See, the situation is given in the question. That situation is
yes, sir.
also true. What you are telling. If suppose the net weight is more than, means sorry, the net weight is positive basically. Okay, or the actual weight is more than the buoyant force, then definitely the body will move downwards, okay. But in this
Yes,
situation,
yes,
looking at the question, it is not that not that case, okay.
mm, yes, sir.
Yeah.
Sir,
Yeah.
sir, in assignment 2, last question was 2 answers, but I cannot able to enter. Only one answer, only possible to enter for
Pardon,
that.
pardon, I'm not getting in
In assignment 2, last 2 questions, there will be a 2 answer.
assignment 2.
Uh,
See,
yes,
yeah, for mean assignment that you have already that you need to submit for this week, no.
yes, sir. Yes, sir. Two answer for that. I can able to put only one answer, sir. I cannot able to separate them by comma
Separate,
or
yeah, yeah,
anything else.
yeah. In that case,
Uh,
you please leave this particular doubt, no, means this question in the discussion forum, okay, and
okay,
it will be
okay,
addressed properly.
okay, sir. I just mail to Eric also, sir.
Yeah, yeah, you can put a mail, or the best cases.
I just put in feedback form, sir. In feedback
Yeah,
form,
yeah,
I
yeah, that
mentioned
is
that
also,
one.
yeah, that is also fine. And then in future, if you find any like this kind of thing, no, you immediately put it in the discussion forum, okay.
Okay, sir. Okay.
Yeah, yeah,
Thank you.
yeah. Okay, please end for today. Thank you. uh, Bye.
Thanks, thanks, sir.
Yeah.
Thank